Now let us see how absolute positioning or point positioning is done based on the code and phase measurements. Let me explain how satellite positioning is done with code measurements. Consider one satellite and one receiver. We have measured the pseudo range between them. And we already know that the satellite coordinates are known and receiver coordinates, which I show them by R, are unknown. So the receiver clock can also be considered as an extra unknown because it belongs to receiver, like coordinates, not satellite. So we can have it as an extra unknown. In fact, the satellite sends codes continuously down to the receiver, and receiver has the same code and regenerate the same code. And by comparing these two codes, the code that the receiver has generated itself and the code that the satellite has sent to the receiver, the receiver recognize how much the signal has been on the way from the satellite to the receiver. This is why it is called code measurement, because receiver, by measuring the code, its own code, and the satellite code, recognize the time. This is why we call it code measurement. But in any case, when we do this code measurement for one satellite, we observe that we have one equation and 4 unknowns. So we cannot solve this equation only with one satellite. So we have to add another satellite. Now we have 2 equations and 4 unknowns. Not enough. I add another satellite. Now I have 3 equations, 4 unknowns. Not enough. Now I have 4 satellites, or 4 equations and 4 unknowns. This is why we always say that we need at least 4 satellites to determine the coordinate, to determine the position. If we have more, it's much better because we can apply least squares method for have a better estimation for the coordinate, but not less than 4. With minimum 4 satellites, we can have a unique solution for the receiver, not even estimation for the error. Like positioning with carrier phase measurement is a little bit different. So instead of timing, we measure the signal fraction or the phase difference at the receiver. What does it mean? It means that when the satellite sends the signals, receiver generates the same signal. But because of this distance, the received signal has not the same phase as the generated signal in the receiver. And they will have the phase difference because of this distance. And in fact, the receiver measured the phase difference between the satellite and the receiver. One main issue here is that we don't know how many complete wave has been going down to the receiver from the satellite. Or we don't know how many complete circles the signals have completed down to the receiver. This is why we call it ambiguity parameter, because it is ambiguous. And therefore, we have to somehow estimate this ambiguity when we estimate the receiver's coordinate. The mathematical model for the phase measurements is here. This term is related to satellite clock error, which normally the satellites send it and we have a mathematical model for correct it, so we will have it. It's not a problem. Here we have the through range involving coordinates. Here is actually the ambiguity parameter between the satellite and the receiver. And the last term is related to the receiver clock error, which should be estimated at the same time we estimate the coordinates of the point for the receiver. But the question is, we have these ambiguity parameters here. Can we estimate these ambiguity parameters by adding more satellites, as we do for cloud measurements? The answer is no, because each satellite that you add to this system of equation will add an extra unknown for you. So, for example, we know that we need at least 4 satellites to determine the coordinate for the code measurements. But this is not the case for phase. Even if I add 4 equations here, I have 4 extra unknowns as well. I mean, 4 extra unknowns means ambiguity parameter for each satellite. So it's not enough. Then the question is, how can we solve this? We can solve this ambiguity parameter by measuring the phase differences between satellite and receiver in several epochs. For example, I have 4 satellites. If I have 4 satellites, I have 4 unknown parameters extra for the ambiguity, and I already have 4 parameters for the satellite clock error, the receiver clock error, and the position, which has 3 parameters. So therefore, I have 8 unknown parameters to estimate. 4 satellite is not enough. But if I measure the same 4 satellites twice, it means that I will have 8 equations. But since the ambiguity parameter is not changing, therefore I can keep the number of unknowns 8. So the number of unknowns, the ambiguity doesn't change when the satellite moves. That's the principle. So if I have 4 satellites, I need to measure the phase difference or carrier phase at least 2 epochs. It means the 4 satellites twice in 2 times. So in this case, I can have a unique solution. If I can have more epochs, even better. I can have an estimation even for the error.